look at, we're going to again compare to the x squared, which I have already sketched out. That's our basic parabola. But now we're going to, instead of adding and subtracting, we're going to multiply the x squared by a number. Here I'm using the number 2. And so we're going to go ahead, fill in our xy table again. We'll do this a little bit quicker with fewer values, and I think you'll get a feel for what's going to happen here now that we've done this a few times. So again, we plug in to the x squared function and just square each of these numbers. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now with the g function, you're going to again plug the x value in, square it, and then multiply by 2. Okay, so you square and then multiply by 2. So 0 squared is 0, multiplied by 2 is still 0. Right? 1 squared is 1, multiplied by 2, that gives us 2 this time. 2 squared is 4, 4 times 2 gives us 8, and 3 squared is 9, 9 times 2 gives us 18. Okay, so these are the corresponding points with x values 0, 1, 2, 3, and when I plot them, well, 0, 0 is in the same location, still in the origin. 1, 2 is up a little higher than normal, and 2, 8, 2 over and 2, 4, 6, that's 8 up. And then 3, 18. Well, if I go over 3, I can't get 18 up. I didn't leave enough space for that. But that's okay. I've got 3 points here. I should be able to get a sketch using those 3 points. And if I use the idea of symmetry here, I know that the graph on the right is going to be symmetrical to the graph on the left. So I could repeat these points on the negative side, right? So it would be negative 1, 2. It would be the same thing, right? If I square the negative 1, I would get 1, and then multiply by 2, I get 2. So I can repeat these negative 1, 2, negative 2, 8, and get another, or the other side. Of the graph. Okay, so what I want you to notice here is that the new graph, the purple one, is sort of narrower than the original. It's pulled taller or stretched out. And so if you can imagine taking hold of the original graph there, the x squared, and pulling it away from the x-axis, what you'll get is the purple graph. Okay, so essentially what happens is every point doubles its distance away from the x-axis. So if at 2, the original graph had a value of 4, it's 4 units away, then the new graph is going to be 2 times that away, which would be 8. Okay, so the distance here is double. Alright, so it's pulling away. Now, we call that a vertical stretch. And what I want to show you now is I'm going to go transfer over to my calculator for a moment, and I'll show you that the bigger this number is that's multiplying the x squared, the narrower the graph will get. It's going to be stretching it more and more. So if I go to my calculator, let's get rid of that. I'm just going to go to my y equals screen. I already have some functions entered in here. Here we go. So I've got x squared as my first function, 2x squared, which is the one I just showed you, and then I'll go 5x squared and 10x squared just to give you a better feel for this. Okay, so now I'm going to go to the zoom feature and go to zoom standard. Hit the 6. There's x squared. There's 2x squared. You can see I'm plotting. There's 5x squared. and 10x squared. Okay? Now, it's a little bit hard to see it here because of how crunched it is. So let me readjust the window for a moment and just kind of, focus our attention in on this region where the graph is. So let's go to window. We'll go maybe -7 to 7. And then the y direction -1 up to, I don't know, 20 maybe. And hit graph. And so now I'm focusing in. There's x squared. There's 2x squared. That's the narrower one. There's 5x squared, even narrower. And 10x squared, that one's even narrower yet. And so you can see how the increase in that multiplier is going to lead to a narrower and narrower graph, a stretching away from the x-axis. What's also interesting is if I were to include some smaller values instead of getting bigger and bigger, like 2 and 5 and 10, if I were to use smaller values, it's going to open it wider instead of narrower. I can show you that in a moment. So let me summarize this for a second. Going back to my sheet here, we're going to say in general, we'll say that y equals a times x squared is a vertical stretch of x squared by a factor of a when a is bigger than 1. Okay? So as long as this a value, a is the coefficient, is bigger than 1, like 2 or 5 or 10, you're going to get a vertical stretch. Okay? Now, like I said a moment ago, if we were to change that up, if I go back to my calculator, I'll try to run through these pretty quickly. Let's start with x squared, but then let's change this to 0.5, 0.25, and 1, so the 0.1. So it's getting smaller. And if I go to my graph, we'll use the same window. There's x squared. There's 0.5x squared, 0.25x squared, 0.1x squared. Okay? And so again, you can see this time we're kind of pressing the graph in toward the x-axis in what we call a vertical compression. All right, so let's say y equals ax squared is a vertical compression when a is between 0 and 1. Okay, so when a is between 0 and 1, you get a compression. It's flattening it back out, you're getting wider. So in the first case, the graph gets narrower. In the second case, the graph gets wider. Okay. Now, the other situation occurs when, instead of a being greater than 1 or between 0 and 1, let's say a is actually less than 0. It becomes a negative number. Well, then if you can just imagine for a moment, rather than sketching it out, what would happen if this was a negative number, if this a value were negative, basically you're just multiplying by a negative and all these outputs become negative. It just takes the graph, instead of pointing it upward, all of the values become negative, it points downward. So positive 2 would become negative 2, positive 8 would become negative 8, and that graph would come down instead of up. Okay? So, just very quickly, I'll summarize that for you. We'll say y equal ax squared is a reflection across the x-axis when a is less than 0, okay, or negative. And that reflection we often call opening down. Okay, so the graph would open down if that's the case, rather than opening up like we see it here. All right. Okay, notice though that by multiplying by this number, we are not moving the graph around. We're not shifting it like we did in the previous examples. We're just doing a stretch if the a value is bigger than 1, a compression if the a value is between 0 and 1, and a reflection if the a value is negative.